All right, guys, it is almost time for your AP exam. So we are just going over our periodic table and equation sheet. You should have gotten some copies from me and just practicing some of the things we could add to this to help us create a more useful document. Right now we've got our periodic table. It does have the group numbers on it, but it doesn't have very many other things. So the first thing I would add to your periodic table is just to go down the side, the left side, and add the period numbers so that when you're referring to periods, energy levels, all of that, it's a quick reference and you're not having to count your energy levels or your rows, okay? One other thing I would add here would be your orbitals. So like your first two columns, your S orbital. Over here you've got your p orbital. I know some of the copies you have maybe don't have these last few elements down here, but that's okay. That section though is your p orbital. You could even add some lines if that helps you. Your center section, you can always do it up here, is your d orbital, and then you got F down here, which we typically don't have to use. Something I'll throw in just as a reminder, anytime it asks you for valence electrons, it's only going to be your S and your P for valence. It's for that element. So say we want valence electrons for arsenic here, it'd be 4s2, 4p3. We don't care about the d orbital because they're not on the highest energy level. They're not valence. Okay, another thing I might add is the charges. We got 1 plus charge, 2 plus charge, 3 plus charge. We don't have a charge for group 14 there because there's no real pattern. 3 minus, 2 minus, 1 minus. That can help you with a quick reference on those. If you really want it, maybe adding, a little side note on your trends, like that atomic radius increases going that way. And then ionization energy and electronegativity increase going the other way. Fluorine is your greatest electronegativity, that kind of thing. Those might be helpful for you as well. So taking just some time to practice what you would add there, seeing how much time it takes you. Maybe it only takes you 10, 15, 20 seconds. That is worth your time at the beginning of the test to make sure this is an easier working document for you. Let's take a look at our equation sheet. Some reminders just to look over your equation sheet. Remember that you've got things like what your units stand for, in case you don't remember some of those. Remember that if you look for an equation and you don't remember what the symbol is for something, say a question says, gives you wavelength, but you're like, I don't remember what the symbol for wavelength is. You've got information like that over here. It tells you what your variables are. And then you can look and say, okay, well, what's the equation to plug that into? If you look maybe at that second equation and say, well, I don't know what C is, look back over here. You've got a value for it. So use those resources, use those tools to help you as you have this test. So in terms of adding things to this section, oh, I've got the old version of this one too. So your equation sheet should have, on your test, will have an extra equation, AT minus A0 is negative KT. So one thing I would label on here is that's your zero order reaction. This one's your first, this one's your second order, and then their half-life equation is always first. So 0 first, second first. That could be just, again, an easier quick reference when you're doing rate law stuff and you might need to use one of those. I'll point out over here, you've got all your K values, all your equilibrium constants. It's telling you what it's for, C, P, A, B, W, using that. And then you've got your pH equation, stuff like that. Something you might want to add is that your hydrogen or hydroxide ion or to undo any of the things with a P, basically, it's 10 to the negative of that value. So hydrogen is 10 to the negative pH, hydroxide would be 10 to the negative pOH. your pKa to find your Ka. You could remind yourself Ka equals 10 to the negative pKa. That could be another helpful equation there, but anytime to undo anything with a p in front, it's 10 to the negative of that value. So there's not much I would add on this particular equation sheet, just kind of pointing out some of that, just a few little things. I would, however, add a few things to this equation sheet. Just let's look over some of the equations. Again, you've got your list of constants over here, or your list of variables and constants. Don't forget those are available to you. And all that, so you've got those. Also, you've got your ideal gas law at the top, you've got your partial pressures, your mole fraction, all of that. It does give you your molarity equation. We're pretty used to using that, but it writes it in words, so if you maybe wanted to jot it down real quick in letters, you could. In our stuff on acids and bases, many of you guys learned about M1V1 equals M2V2. You could use that. And then down the bottom, we've got our thermodynamics and electrochemistry stuff. So our Q equals MC delta T, our S, delta H, delta G. You might do that delta H can be bonds broken minus bonds formed. That might be a good reminder when you're looking at bond energy. And then the other thing you might add is just a little reminder, ooh, that was a mess, on our heating curve. So we start with a solid, we go liquid, we go gas. Here is going to be melting, and here is going to be boiling. Boiling is always a longer line because it takes more energy to break all the intermolecular forces. And I will remind everybody here that we are breaking intermolecular forces when we change states of matter. When you melt or boil, it's intermolecular forces. When you condense or freeze, you are forming intermolecular forces. You are not breaking bonds, and that is one of the key ways you can just lose your points on FRQs, is if you say breaking bonds when you're not going through a chemical reaction. Okay, so to break bonds, it has to be an actual chemical reaction. Products and reactants, that kind of thing, okay? In this curve, you could also add that going up, your delta H and delta S are both positive. If we go the reverse direction, we cool things down, delta H and delta S are both negative. So that could help you out in some things there. Otherwise, I think this is pretty useful. You might throw somewhere on your equation sheet or wherever you've got room on your periodic table, you could add your where's our acid-base stuff? I think that's on our front page. So maybe next to your acid-base stuff, you could add the strong acids that are HCl, HI, HBr, not fluorine, HNO3, HClO4, and H2SO4. Your strong bases, you can remind yourself any group 1 or 2, metal, plus your hydroxides to balance the charge, okay? Any group 1 or 2. The other thing you might add is your always soluble ions, which are sodium, potassium, ammonium, and nitrate for your negative. If it has one of those, it's going to be soluble aqueous, right? Oh, I wrote Ka, so used to equilibrium, so K plus, all right? So those could also always be helpful as well to jot down. So a few things here, got a few equations, strong acid, strong base, what's always soluble. So those would be helpful as well. Practicing this a couple times, just jotting it down so that you've got it. You can write it in, again, those first few seconds of your test. can make these a lot more useful again and have a better reference sheet for you. So I hope this helps. You guys got your test coming up. You got this. I believe in all of you. So I will see you soon. Good luck.